this session we will be discussing practice questions. Whatever we have learned in the process synchronization chapter, we will discuss all the questions of process synchronization one by one in this session. Okay, and all the questions are previous year gate questions. Okay, we will discuss each and every question in detail. Okay, so let us start. This is the very first question, my dear friend. This is the very first question, and I will give you for every question 1 minute, guys, to recall the concept. So I am giving you here, if you want to feel what offline classes or live classes feel, okay, then please give me the answer of this question by yourself. Take your 1 minute. Take your 1 minute and try to give me the answer. I hope you are able to give the answer of this question. I hope you got the answer of this question, my dear friends. A critical region is what? Critical region means is what? Critical section. Okay. So in every process we have two sections. First one is what? Critical section, and second one is what? Non-critical section. Okay. Means some instructions of the process need synchronization and some instruction of the process doesn't need synchronization. Okay, understand. So critical section, as I told you the definition, my dear friends, critical section is a portion or section of the process or of the program where process can access the shared resources, okay, during its execution. Means critical section is a place where shared resources are available of the processes. Okay, so one which is enclosed by a pair of P and V operation, no blunder option. A program segment that has not been probed work free, blunder option. A program segment that often causes unexpected system crashes, blunder option. A program segment or section, okay, where shared resources are accessed, yes, where process can share the shared resources, okay, can access the shared resources during its execution. Okay, so option D is correct here. I hope you understand this question. Okay, so I am going to move on the next question. This is your next question, my dear friends. This is the fill in the blank type question. Okay, semaphore operations are atomic because they are implemented within the OS kernel. So please remember this. Semaphore operations are atomic because semaphore operations are implemented within the OS kernel. Okay, within the OS kernel. Please remember this point. I am going to move on the next question, my dear friends. This is your next question, and try to solve by yourself. I am giving you here 1 minute. Okay, 1 minute is sufficient for this question. Try to by yourself, my dear friends, to get the confidence over that type of question. I hope you got the answer, my dear friends. Okay. So now I am going to read the question. At a particular time of computation, the value of counting semaphore is what? 7. Okay. So value of counting semaphore is given here as equal to how much, my dear friends? 7. Okay. Then on that counting semaphore, 20 P operations. P operations means is what, my dear friends? Wait operation, down operation. 20 wait operations. Okay. And 15 B operations. B operations means is what? Release operation, signal operation, up operation. Okay, up operations were computed on this semaphore as the resulting value of the semaphore is what? Wait operation means is what, my dear friends? P operation means is what? Down the semaphore value by 1. Okay, and V operation means is what? Up operation means is what? Up the or increase the counting semaphore value by 1. Okay, so here 20 P operations, so minus 20. Okay, and 15 B operations plus 15. Okay, so what is the final value of counting semaphore? 15 7 how much? 22. 22 minus 20, this is the final value of the counting semaphore. What is, my dear friends? 2. What is 2? Option A is wrong, option B is correct here, option C is wrong, option D is wrong. Okay, option B is correct here. I hope you got the answer, my dear friends. Okay, so now I am going to move on the next question. This is your next question, my dear friends. They repeated. Okay, this question asked in again in GATE. Okay, so try to give me the answer fast. Try to give me the answer fast. Okay, so a critical section is a program segment. Just try to get your answer. Okay, I hope you got the answer. A critical section is a program segment which should run in a certain amount of time. No, my dear friends. Which avoids deadlocks. No. Where shared resources are accessed. Yes. Where critical section is a place where shared resources of the processes are available. Okay, yes. Okay, which must be enclosed. No, blunder option. So option C is correct here. I hope you got the answer. Okay, very good question. Okay, now I am going to move on the next question. This is your next question, my dear friends, and I hope you are able to give the answer. This is a very logical and very good question. So here I am giving you 2 minutes. Try to solve by yourself. Try to solve by yourself, my dear friends. I am giving you here 2 minutes. Okay, I am giving you here 2 minutes. Just try to solve by yourself. Okay, you will understand. Just go on the dining philosopher problem. Okay, and try to recall the concept. Try to recall the concept. Okay, I am going to read the question. A solution to the dining philosopher's problem which avoids deadlock is 2. Which avoid deadlock is 2. We have discussed. Means whatever n minus 1 processors n minus 1 philosophers is doing, the last one will need to do only one processor need to do just opposite. Okay, so when you will think logically, then you will able to get the answer. Otherwise you are not able to get the answer. You will confuse. So I hope you got the answer. Okay, I am going to explain a solution to the dining philosopher's problem which avoids deadlock is 2. Okay, if as we have discussed. Okay, if there are 10 philosophers, then all the 9 philosophers picking their left fork first, then after picking the left fork first, they are able to pick the right fork. Okay, okay, means on, so out of 10, 9 are doing the same task and 10th philosopher need to do just opposite task. Okay, from all, just opposite from all other 9. Okay, just opposite. Okay, So here which option is correct according to this? Okay, ensure that all philosophers pick up the left fork before the right fork. This, if they are doing this, then there is a deadlock. Ensure that all philosophers pick up the right fork before the left fork. As we have discussed, as I told you here, whatever, so out of 10, whatever 9 is doing, 10th one is doing just opposite, then only there is there is no deadlock. Okay, so what we have restricted there, all the philosophers need to need to take their leftmost fork first, then they can take the rightmost fork. Okay, but here and the 10th one need to pick their rightmost fork first, means just opposite task. 10th philosopher need to do just opposite task. So according to that concept, option C is correct here. Ensure that one particular philosopher pick up the left fork before the right fork. If all are doing, if all others philosophers pick up the right fork before the left fork, if all other philosophers are doing this task, then only one particular philosopher need to do the just opposite task from the other philosophers. So that's why according to this concept, okay, option C is correct, my dear friends. I hope you understand clearly. This is our next question, my dear friends. Try to read this question carefully and try to solve this question, because we have executed various codes. Okay, we have executed various codes. So in the process synchronization questions, they will give you the code. When you are able to execute the code, then you are able to solve each and every question. Okay, so I am going to read the question, my dear friends. After this, I will give you 2 minutes. If you want to take here offline classes feel, live classes feel, okay, then I will give you here 2 minutes. Try to solve this question by yourself, and then after 2 minutes I will solve this question here and try to match your answer with my answer. Okay, so each process Pi, okay, where I equal to 1 to 9 means P1 to P9 processes is coded as follows. P1 to P9 processes will execute this code. The code for P10 is identical except it uses B mutex in place of P mutex. The code for P10 is also identical, okay, but there is only one difference. At the place of P mutex, P10 will use what? B mutex. Okay. What is the largest number of processes that can be inside the critical section at any moment? Okay, you need to calculate at any moment what can be the largest number of processes inside the critical section. So I am giving you here 2 minutes, guys. Try to by yourself, try to execute the code. Try to execute the code again and again and try to get the answer. So I am giving you here 2 minutes. I am giving you here 2 minutes. My dear friends, try to yourself. Okay. Then I will solve here this question. I think you are able to execute the code. We have executed various codes. Okay. So now I am going to solve this, guys. If you are not still able to solve this question, okay, then please pause the video and try to solve, then match your answer with my answer. So here we have P1 to P9 processes, P1 to P9, all the processes will execute this code, and there is a difference between P10 code. P10 will execute this code, okay, but there is only one minor difference. P10 will use B mutex at this place of P mutex. So P10 code is what, my dear friend? Process P10 code is what? Here is what it will use, what? B mutex. Okay, mutex. Okay, then it will go into the critical section, and here is what? V mutex. Okay, and here is what? Forever. Understand clearly? So here V means is what? V means is what? Up operation. Okay, and P means is what? Down operation. Where P means we need to perform down operation, where we need to perform what? Up operation. Okay, so listen me carefully. So here mutex is a binary semaphore, so I am taking the value of mutex. I am going to initialize the binary semaphore with value of 1. Okay, with 1. Okay, so when P1 wants to go into the critical section, then yes, mutex value is 1. Then P1 can perform the down operation. P means is what? Down operation. So it will become what? It will make this mutex 1 to 0. It will perform down operation. Okay, on the mutex. Okay, it will go into the critical section. Yes, it can go into the critical section. Suppose P2 wants to go into the critical section. So P2 is not able to here what? Perform the down operation because mutex value is what? 0. Okay, P2 is not able to perform down operation on mutex. So it will go to the suspended list. It will block here. Okay, and it will go into the suspended list. So P2 will go into the suspended list. Okay, now suppose P10 comes and P10 want to go into the critical section. Okay, so P10 is entry code is what? B mutex. Okay, so it will perform up operation here. So it can, when it will perform up operation, then it can go into the critical section. Okay, so one up operation will break this process from the suspend list P2. Okay, suspend list P2. So P2 will try again. So yes, P2 now perform the what? Down operation on mutex, because mutex value is 1. So perform down operation. Okay, P2, and can enter into the critical section. Yes, P2 can enter into the critical section. Now P3 tries. Okay, then P3 can enter into the critical section. So yes, no, mutex value is what? 0. So P3 will, when P3 will perform the down operation on mutex, it will block, means it will go into the critical section. My dear friends. Okay, it will go into the critical section. Now P3 completed their execution in critical section. It want to leave the critical section. It will again perform the up operation. What, my dear friends? One up operation, and up operation of this P10 process will break this process again. Now P3 want to try to enter into the critical section now. Yes, now P3 can perform the up operation, can perform the down operation. Yes, P3 can perform the down operation now. Now P3 can enter into the critical section. Okay, so it completed their critical section. Okay, it leaves the critical section. Okay, so at that time, how many processes we have? P1, P2 and P3. Now suppose P4 wants to enter into the critical section. So P4 can perform the down operation. No, my dear friends, because mutex value is 0, we cannot perform the down operation. P4 cannot perform the down operation. So P4 will go into the suspended list. P4 will block here. Okay, now again suppose P10 want to enter into the critical section. Okay, P10 again want to enter into the critical section. It will perform up operation. So it will make this 0 to 1, and it will make this P4 process. Now P4 will try to enter into the critical section. It will enter. Yes, definitely it will enter. P4, it will enter. Okay, it will enter, and it will make this 1 to 0. P4 make this 1 to 0 by performing down operation. Now suppose P5 want to enter into the critical section. So P5 can enter into the critical section. No, my dear friends, because P5 when perform the down operation and mutex value is what? 0. So it will block. So P5 will go into the suspended list. My dear friends. Now P10 want to leave the critical section. It will execute this up operation. So it will make 0 to 1 what? Okay, mutex value 0 to 1, and it will wake up this P5 process. So P5 can go into the critical section. Yes, P5 go into the critical section because it is able to perform the down operation. So now P5 performs the down operation, and P5 can go into the critical section. Okay, P6 can go into the critical section. No, because when P6 will perform this down operation, then mutex value is 0. It will block. It will go into the suspended list. My dear friends. Okay, it will go into the suspended list. So now again P10 wants to come into the critical section, so it will perform this up operation, okay, and after performing this up operation, it will wake up this P6, okay. Now P10 come into the critical section. Now P6 can enter into the critical section, yes. Now mutex value is what, 1. It can perform the down operation. It can perform the down operation. Now P6 can enter into the critical section. P6 can enter into the critical section. Now P7 wants to go into the critical section. P7 can go, no, because when P7 will perform the down operation, then here mutex value is what, 0. So it will block, okay, it will block, P7 will go to suspended list, okay, P7 will go to suspended list. Suppose P10 completed their execution, okay, P10 completed their execution and want to leave the critical section, it will execute this up operation. So it will make this 0 to 1, it will make this 0 to 1, 0 to 1 and wake up this P7 process, okay. So P10 again comes here and wake up this process, okay, okay, understand? So listen me carefully, okay. So now when this P10 complete will execute this code, then it will make 0 to 1 and wake up this P7 process. So now P7 can enter into the critical section, yes, P7 can enter into the critical section here, okay, P7 can enter into the critical section here. Can P8 can enter into the critical section? No, my dear friends, here, okay, P8 cannot enter into the critical section, okay, by making this okay, 1 to 0, by making is what, 1 to 0, P7 can enter into the critical section. Now P8 can enter into the critical section, no, my dear friends, it will go in the suspended list, it will go into the suspended list. Now suppose P10 want to come into the critical section again, okay, so it will perform the up operation, it will perform the up operation, means it will up this value mutex 0 to 1 and wake up this process P8 also. So now P8 can go into the critical section, yes, P8 can go into the critical section. P9 and P8 will make this 1 to 0. Can P9 go into the critical section, my dear friends? No, because it is not able to perform the down operation, okay. So it will go to the suspended list, it will go to the suspended list, okay. Now suppose, so here P8 is comes, now suppose P10 complete their execution, it want to leave, it will execute this exit code, mutex, it will make this 0 to 1 and wake up this process P9 and wake up this process P9. So P9, wake up this process P9, my dear friends, wake up this process what, P9, understand, wake up this process P9 and P10 leave the critical section, okay, and P10, now P9 can perform the down operation, yes, okay, and enter into the critical section, P10 leaves. Now again P10 want to come into the critical section, so there is a what, my dear friend, down, mutex value is 0, so it will make this what, 1, it will perform up operation, so P10 is there. So at this moment clearly you can see all the processes P1 to P10 at this moment, all the processes into the critical section, at this moment, okay. So now this okay, now I hope you are able to understand, okay. So now this way you need to execute the code. So at this moment we have all the 10 processes into the critical section, inside the critical section, P1, P2, P3, P4, P5, P6, P7, P8, P9 and P10, okay, P10, okay. So here option A is wrong, B is wrong, C is wrong, D is correct here, my dear friends. All the 10 processes can present at this moment into the critical section, my dear friends, okay. I hope you understand clearly this question. So you need to execute the code, my dear friends. You will get the answer each and every question. You will get the answer of each and every question, my dear friends. So every time when P10 will come, it will wake up two processes, okay, from the suspended list to the, okay, ready queue, okay. I hope you understand clearly this question. So now I am going to move on the next question. You need to execute the codes, okay. So this is your next question. I hope you are able to give the answer. For that type of question. I will give you 1 minute, and I hope when you will recall the concept, whatever we have learned in the process synchronization, then you are able to solve this question, my dear friends. Okay. when you will recall carefully all the concepts. Question is what? When the result of a computation depends on the speed of the processes involved, there is said to be, as I told you, as I have discussed, okay, when result is depending on the order of processes execution, okay, which is involved, then that condition is said to be what, my dear friends? Please try to recall. So they will give you the question like this. You need to recall the concept, okay, you need to recall the concept and try to give me the answer. So I am giving you here 1 minute, okay. I hope you got the answer, my dear friends. When the result of a computation depends on the speed of the processes involved. Okay. When result will depends on the execution order of the processes, speed of the processes. They are said to be, my dear friends, cycle stealing. No. They okay. They are said to be what? Race condition. Okay, they are said to be race condition. So I hope you understand and you got the answer. Option B is correct here. So now I am going to solve the next question, my dear friends. Okay. This is your next question. I hope you are able to give me the answer. Okay. So I am giving you here again 1 minute. Try it by yourself, my dear friends. Whatever we have learned, try to recall all the concepts. Go there and try to do by yourself, because when you will do that type of question by yourself, then you will get the confidence over the over the concept. So I hope you got the answer. So I hope you got the answer of this question, my dear friends. Now I am going to solve this question. Okay. Now I am going to solve this question and you will relate this code from any classical problem. Okay. Now just listen me carefully. So here we have how many semaphores? Binary semaphores M0, comma M1, comma M2, comma M3, comma M4. And I am going to initialize all the binary semaphore with the value of 1. Okay, and I have here five processes P0 to P4. So P0 will execute this code, P1 will execute this code, P2 will execute this code, P3 will execute this code, and P4 will also execute this code. Okay, suppose P0 is going to execute P0 want to go into the critical section, it will execute this entry section code. Okay, so it will perform the down operation. It will perform the down operation on what? It will perform the down operation on it. It need to perform the down operation on both M0 and M1. First I am going to write down. Okay, so if P0 want to go into the critical section, it need to perform the down operation on M0 and M1. M0, it requires what? M0 and M1 need to perform the down operation on both. Then only when it will perform the down operation on M0 and M1, then only it can go into the critical section. Similarly, when P1 wants to go into the critical section, it need to perform the down operation on M1 and M2. Listen me carefully. Then only it can go into the critical section. First I am writing all this. Okay. When process P2 will execute this code and want to go into the critical section, it need to perform the down operation on. It need to perform the down operation on M2 and M2, this is a 2, M2 and M3. Suppose P3 will execute this code. Okay, P3 want to go into the critical section, it need to perform the down operation on. It need to perform the down operation on. Okay, down operation on. Here I value is what? 3. Down operation on, my dear friends, down operation on M3, and from here 3 plus 1 mod 4. Okay, 3 plus 1 is what, my dear friends? 4 mod 4. So what remainder will come? 0. So it need to perform the down operation on M3 and M0. M3 and M0. M3 and M0. Okay, so it requires what? M0. Understand? And when process P4 wants to go into the critical section, then it needs to perform the down operation on M4, and from here 4 plus 1 mod 4 means 5 mod 4 what? 1 on M1. Okay, so listen me carefully. Suppose P0 want to go into the critical section. Okay, and when it performs the down operation on M0, it prims. Okay, it prims. Okay, now when P1 comes and when it performs the down operation on M1, okay, and when it is going to perform the M2 operation, then it prims. After this wait operation, down operation, P1 also prims. Now P2 also prims. Okay, P2 also prims after. Okay, so when P0 comes, then P0 will perform the down operation on M0. It is going to make it what? 0. P1 comes, P1 performs the down operation on M1. Okay, means 0. And after performing down operation on M1, P1 also prims. P2 comes, P2 performs down operation on M2, and after performing the down operation, it also what, my dear friend, prims. P3 comes, P3 will perform the down operation on M3. Okay, on M3. Okay, on M3. So it will perform the down operation on M3 and it also prims. Process P4 come, it need to perform the down operation on M4, means only performing the down operation on M4. Okay, it will also primed. Suppose now P0 is resuming again. So it performed this down, it performed the operation this. Okay, it performed the already down operation on M0. So when it will try to perform the down operation on M1, then it will block. then it will what, my dear friends? It will go into the suspended list. It will block. Now suppose P1 resumes. Already performed the down operation on M1. When it will go to perform the down operation on M2, then here M2 is what, 0. This is the binary semaphore. So it is not able to perform the down operation on M2. So P1 also block. P1 will also go into the suspended list. Now P2 resumes. So it already performed the down operation on M2. When it will go to perform the down operation on M3, and can it perform the down operation on M3, my dear friends? No, it is not able to perform down operation on M3. Okay, so P2 will go on and into suspended list, means P2 will also block. When P3 comes, P3 resumes. So P3 already performed the down operation on M3. So when it will go to perform the down operation on M0, so it is all, here value is what, 0. So can it perform? No, my dear friends. It will go into block, means it will also go into suspended list. Now when P4 comes, so it already performed the down operation on M4. When it will go to perform the down operation of M1 to go to the critical section, so can it perform, my dear friends? No, it will also not perform. So it will also go into the suspended list. So now this way all the processes are depending on each other. Okay. So P1 already performs down operation on M0, but to go into the critical section, these two codes need to execute. This is the entry section code. It need to perform the down operation on M1, but this down operation but this M1, okay, holds by this P1 process. Until P1 will not reach this one, will not perform the up operation on this one, then P0 will not able to execute. So here P0 depends on P1, P1 depends on P2, P2 depends on P3, P3 depends on P4, okay, and P4 depends on what, P0, okay. So there is a deadlock situation. There is a, my dear friends, deadlock situation. There is a what? I hope you understand this code. Okay. So you need to execute the code, my dear friends. Okay. Deadlock situation. And if you want to recall this code with any other classical problem, then this is a, my dear friends, Dining philosopher problem. This code is similar to the Dining philosopher problem. Okay, if you remember the Dining philosopher code, then in the anti-section code we need to perform, okay, any philosopher need to perform, okay, 2 wait operation, 2 down operation. Okay, understand clearly? Means on, suppose P0 philosopher will come, so on F0 it need to take what, my dear friends, left fork, means ith fork, then ith plus 1 fork, and need to perform the wait operation on this. Okay, so I hope you understand clearly. This is a Dining philosopher problem. Okay, different code. So if you will execute this code like this, then you will also get these processes depending on each other for their execution. So no one is able to execute completely, okay, and no one is able to enter into the critical section, or are blocked. Okay, all are depending on each other. So this situation is called, my dear friends, deadlock. I hope you understand clearly this question. So please note it down if you want to note it down. Okay. So execution, execution is important. If we are able to execute the code, then you are able to solve any question of process synchronization, my dear friends, and it is very easy. I hope it is okay. You are also thinking like this. It is very easy. Process synchronization very easy, my dear friends. You need to execute only the codes. My dear friends. So when you will execute more and more codes, then these questions are very easy. Will be very easy for you all, guys. So I hope you understand clearly this question. Now I am going to move on the next question, guys. Okay, this is a different question. Okay, so try to solve this question, my dear friends. Again, if you are able to recall the concept, okay, then this question again is very easy for you all, guys. Okay, I am going to read the question. Consider Peterson solutions. Okay, here also given what? Consider, this is a Peterson solution, my dear friend. Consider Peterson solution algorithm or Decker's algorithm. Okay, also it is known as what, Decker's algorithm, for mutual exclusion between two concurrent processes I and J. Here we have two processes I and J. The program executed by processes is shown below. This is a program, okay, for the Peterson solution, where, and Peterson solution, you know, restricted for only two processes. Okay, means it can provide the synchronization among the two processes only. So here it is using two processes, I and J, and this is a code, my dear friends. For the program to guarantee mutual exclusion, the predicate P in the while loop should be, what will be the code for this? Okay, while loop P. Okay, while loop P. Okay, understand clearly, my dear friends? Do no operation. Do no operation. Okay. So I am giving you here 2 minutes, guys. If you are able to execute the, if you will execute this code line by line, then you will get what we need to put here in this while loop P part. Okay. So I am giving you here 2 minutes. Try to recall by yourself. Okay. Understand, here we have two processes, I and J. Suppose I is interested. Here they are using flag. As I told you, either you can use flag or interested variable. So they are using flag. Flag means it's what, interested. Okay, process. So two processes, I and J. Try to execute this. Okay. As we have executed the code, guys, many codes. Okay. For the program to guarantee mutual exclusion, the predicate P in the while loop should be, just reply me fast, I am giving you 2 minutes. Okay, here. So now I am going to solve this question. Listen me carefully, my dear friends. Here in the Peterson solution, they are using what, flag. Flag means is what, interested. Interested or flag, whatever you want, you can use in the Peterson solution. So I am going to execute this code. Suppose I want to go into the critical section. I want to go into the critical section. I is interested process which can go into the critical section. So flag of I equal to true. First we need to, in Peterson solution, first we need to take the interested variable. Here they are using flag variable. Okay, value is what, false for both I and J, for both. Here this is I, this is J. Okay, and here we are using what, turn variable. Here we are using what, turn variable. Okay, so I want to go into the critical section. This is the interested process. So make flag of I equal to true. Okay, flag of I equal to true. So here it is false, make it what? True. Okay, turn equal to j. Okay, turn equal to j, put in the turn variable is what, my dear friends? J process. Okay, while p do no operation. Okay, while p, so to go into the critical section, I process to go into the critical section, we need to put what, my dear friends? Into the p portion in the while loop. Okay, so in while loop we have two condition. In Peterson solution, while loop we have two condition, my dear friends. Okay, so I need to break the while loop condition, then only it can go into the critical section. So I is interested here. So what should be the code, my dear friends? If anyone, out of two, anyone is what? False, then while loop condition breaks, I process can go into the critical section. So here we will put two things. So when through the option you can check, when we will put this flag of j equal to true, flag of j equal to is what, my dear friends? True, and turn equal to what? I. So I is interested, my dear friends. I is interested, and here we are putting on turn equal to what? J. So turn equal to what? I. Turn equal to what? I. And flag of j equal to is what? True. Flag of j equal to here is what? False. And turn equal to what, my dear friends? Here I. So we need to make it what? J. Okay. So option A cannot be your answer. Option A cannot be your answer. Come to option B. Flag interstate process is what, my dear friends? Interstate process, flag of j equal to what? True, and turn equal to j. So flag of j. So j is what, my interstate? Okay, j is what? Flag of j is what? False. It is not true. So here one process, here one thing is what? This is false. This is false, my dear friends. This is false. This is false, and it is true or false doesn't matter in the Peterson solution. When one condition is false, okay, then it breaks the while loop condition and it will enter into the critical section. It will enter into the critical section. Okay, so we need to put this flag of j equal to true, flag of j equal to true, and turn equal to j, and turn equal to j. Here flag of j equal to what, my dear friends? False. So we need to put this here. I hope you understand clearly. Okay, so you need to execute. Okay, flag of j equal to true, when it will check this, and turn equal to j, and turn equal to what, my dear friends? J. So when it will execute this, then this will break the while loop condition, my dear friends. Then that I process enter into the critical section now. Okay, then this I process can enter into the critical section. Understand clearly, my dear friends? Understand clearly? So I is interested in turn is what? J. Turn, okay, is what? J. It is, we are executing the code, my dear friends. So I hope you understand. When it will check flag of j equal to 2, no, flag of j is false. So there is a one out of two, only one condition need to be false. So this is false, means that will break the while loop condition and j I process can go into the critical section. So option B is correct here. I hope you understand clearly, guys. I hope you understand clearly this question. Okay. I hope you understand this question clearly. So please note it down if you want to note down, guys. This is a very good question, my dear friends.